to the next problem on number. I will bring the next problem, that is number 24. It says determine whether the number numbers basically are rational or irrational. Okay, so this is the requirement. The options are given. The first one is root 2, 1.5, root 10 and 3.14. So one by one I will explain. The first one is root 2. Root 2 is not a perfect square. So after the decimal, if I take up to 4, then after these are not of repeated type. Means if I do square root, then 2, 4, 96, 4, 0, 0, 28, 1 to 81, then after it is 9, 1, 1, then 0, 0. If I take 142, 82, then it will be how much? 4 again. So it will give 4 for the 16, 96, 28, 4 into 32, 3, 11. So it will become 4 and then 0 and then 6, 0, 0. If I go on doing this, so this will be 4. So then again it will come 2, 8, 2, 8. If I want to divide it, it will come around 2 times of that. So every time I will get some other number. So that is not a repeating type. So it can't be represented in the form of P by Q, where P and Q are the rationals and Q not equal to 0. This is the condition for a number to be a rational number. The rational number can be represented in the form of 2 and P upon Q, where P and Q are both are integers. So this cannot be. Now 1.5, you can see it is 15 upon 10. So that means 3 upon 2. So it can be well represented in the form of P by Q, where P and Q are integers. So 3 and 2 are integers. So this is definitely a rational number. 10 again is not a perfect square, so it cannot be a rational number, because 10 you are getting as 3, 3, 3, 3 like that. It is a unending. This is not a square up to a perfect decimal numbers. It means it is not a perfect divisible or a perfect you can say the square root. So this also not a rational number. Whereas if you see, by seeing this number, people may confuse, but you should not be confused, because if you assume it to be a value of pi, it is generally we are taking up to the second decimal of that pi value. So if for the sake of the calculation, we always take pi value is 3.14, but exact value of pi is 22 upon 7. So if I go on divide 22 by 7, we won't get a perfect number which will be ending up to the some numbers of the decimal, but it is a non-perfect dividends, that 22. So it cannot give you a perfect decimal number or a perfect. So that means 22 is not a perfect divisible by 7. So you won't get a limit digits after the decimal. So this cannot be the case for pi. So if I assume that it is pi, it not be a correct decision, because 314 can be represented by 314 by. So rather, if you cancel it, I will get around this. If I reduce it further, so it gives you this. So this is well an integer. This is also an integer. So it can represent in the form of PYQ definitely if it is the number. So I can say this is a rational number. But for case of pi, it is not a rational number, it is a irrational number. So don't be confused by seeing this number and say that it is a irrational number. So next comes the sum 25 without actual division. This is without actual division, a state of the following, a state which of the following is a terminating decimal, is a terminating decimal. Okay, so the options are two options are given: 9 upon 25 and 37 upon 78. So in the last problem I was discussing about this term, terminating decimal. That means if I divide some number with a number, then after the decimal, if the digits are limited, that means it is ending with some digits. Okay, so then that case I can say the division is a you can say is a perfect rational number. It is a rational number. That means the things are not extended unlimitedly. It is terminating up to some digits, or rather, if it can be said that some numbers are repeating again and again after the decimal, means let's say 1 2 3 after the decimal, now 1 2 3 again is coming. So in that case also we can say this is a rational number. It is not that the irrational number. But in some cases it is not terminating. It is not it every time it is getting new numbers, and there is no sequence or any pattern it is following. So these are not the terminating. So in these two cases, one thing before to start, whatever be the number in the numerator, it will not affect the number to be deciding whether it is terminating. So only the value that will decide is the denominator. How? Because 1 upon some number, let's say if it is perfectly dividing 1, then with the multiplication of any other number, the form of the division, if it is terminating, the multiplying with b, the state will not change. That means if this 1 by a is a perfectly terminating number, then multiplying with any number, it has to be terminating again. So that means I mean to say, if 1 by 21 it is a terminating decimal number after the decimal, So multiply it with the 3 or multiply it with any other number, let's say 5, the number will be a terminating again. It will not change its state. So the numerator will not take part in deciding the number is terminating or not. Only part that the denominator will decide. So how will it decide? Now if I take the numbers, if I say what is the prime factor, the prime factor for 25 is 5 into 5. So 1 upon 5 is what? It is a terminating one, 0.2, and other 1.5 also terminating. So that means the result of 1 by 2 into multiplied any number will be a terminating one. It cannot be a number which will affect by 19. So 1 upon 25 it is, if I can decide it is a terminating or not, then straightway I can say 9 upon 25 also a terminating. So here I can see 1 by 5. Why I am taking the factors? Because some factors may be terminating, other may not. So the cumulative result would be a non-terminating one, not the terminating one. So every time you have to see the factors, 1 upon that factors, whether these are terminating. So any of the factors which, if it is not terminating, the whole result will be a non-terminating. So in the second case, if I see 78, what are the factors? 2 into, it is 39, means 3 into 13. So now if I take 1 upon 2, it is terminating. Well, 1 upon 3 if I take, it is non-terminating. That means it is go on like that. And again 1 upon 13, again it is non-terminating. Okay. So the two of the result is non-terminating, one may be the terminating, but the whole result 1 upon 78 would not be a terminating one, it is a non-terminating. So this number is not terminating, this is terminating. So our requirement following is a terminating decimal, this one will be answer. Okay. Next comes 26. So 26, this is 26. 26 says express each of the following as a rational number. Express each of the following as a rational number. In the form of P upon Q, where Q not equal to 0, and also that P and Q are integers. This is not said in the exam, but you have to assume it, both are integers. Okay. So this condition is always true as per the definition of the rational numbers. Now the numbers given is 0.6 bar and 0.43 bar. Now here you can see this is, you can say the terminator, because bar means after that every term will be repeating. Means if it is bar on the two numbers after the decimal, so this term will repeat again. Here 6 is at bar, so this again it is repeating. Okay. So I can say, so in this case, let's say I am assuming that this is 6, x is 6 bar, okay, let's say. So the 6 can be written as let's say I'm taking up to the 4 decimal. Okay, I can take it further, but what I want to show, I'm telling you. Now multiplied with the 10. So 10x will be 6 point. Now it is also up to the infinite terms, because if it is going on, it will go on elsewhere. So if I only multiply the 10, so only the decimal will shift one row, and then after it will be infinite. So if I deduct this from this, means this is 1, this is 2. If I deduct this from this, so I will get 9 of x, and I will get, after deduction, after the decimal it is equal, so I will get only 6. So x will be 6 upon 9, that is 2 upon 3. So this is the rational number I am just getting out of it. So you can say that this number where the digits are repeating, then we can say it is terminating one, and it is a rational one too. Okay, so wherever the digits are repeating, in that case the number can be said to be a rational number, and I can represent it in this way. Now if I in turn try to divide 2 by 3, what do I get? If I put decimal and I will get 0, then I follow the rule. So I will get 2 decimal. So again this will follow the same number. So by this process I can get a number which can be represented in form of P and Q, and definitely it is a rational number. And the second one, in a similar fashion, if I take x is equal to 0.43 and I will take up to the 4 digits. Now with the 100x, because this is 2 terms is repeating, so in this case I will to multiply the 100 to get the correct thing. Okay, so now if I deduct from 2 to 1, so 2 to 1 I will get 99 of x, and after the decimal you can assume both the terms are same, so only the things will remain before the decimal. So x will be 43 upon 99, as because both are having no common factors, so it cannot be reduced further. But although this is represented of in the form of P and Q, where P and Q are integers, so this is the rational number I am getting from this number. Okay, in earlier the first sum I explained about root 10, but there I said might be wrongly that root 10 is irrational, but if I try to factorize it, I can get 0, 0, 30, decimal will give you 1 0 here, it will be 0 here by decimal. I will get 2 zeros, so 3 2s are 6. Then if I take 1, then it is 61, it is 9 upon 3, 31, 62, 0 0, then 6 is 36, 6 2s are 12, 12 and 3 15, 1 39, 36 is 36, 1 37, as 4 1 144. Then again, no, there I have to put 6 3 6 32 0 0. If I put 0 2, so in this case it is not repeating. So it is not repeating, it is going on changing its number. So yeah, I was right. Root 10 is a irrational number. I am not getting a repeated one. So in this case, root 10 cannot be a rational number, it is a irrational number. So I was correct in that. I have confusion, that's why I am clarifying that one. So next come my problem number just now 24, 5, 6 here, then 27. Find 4 rational number between 1 and 2. So how do I able to find it? So as because I have to get 4, so in this case you have to remember I have to divide including one number up to 2. There should be one number, 2 number, 3 number. So 5 more number should be received as a rational number. The rational number can be represented P by Q form. Now I have to give this number in the shape of fraction only, because in between 1 and 2 there is no integers remaining. So what I have to do, if I want to divide this number in fraction equally, then I can represent 1 in the form of 5 upon 5 and 2 in the form of 10 upon 5, because the total numbers have to be divided in 5 numbers. So the terminal number is the boundary numbers that is already given 1 and 2, and in between I have to find numbers, 4 rational numbers. So this can be anything, but to give it a uniform form, so I am just representing this number in the form of 5 by 5 and this 10 by 5. So it will be easy for me to find other number, because I only have to put 6, 7, 8 in between, because 5, 6, 7, 8, 9 also be there. Oh, 4, yes, 4 numbers, so 9 also to be there. So these are the 4 in between. So what I have to do, only I have to put 5 in the denominator for each case, because I am just representing number in this way. So this will be easy for you to find the numbers, or otherwise any such number that is coming in between this 1 and 2 would be the answer. But it is a one kind of easy representation where you need not to change other denominators, only the top one has to be changed and it will be easily distributed. Okay, so this for now. Next class I will continue from number 28. Thank you.